We're going to talk about vectors now. So this is our beginning into 2D kinematics. We're going to start with just an introduction to vectors again. A lot of this is going to be review. And then we're going to look at doing 1D vector addition. So first, let's talk about what a vector and scalar quantity again, since this definitely matters when we're talking about vectors. So a vector quantity is something that has direction and magnitude. So that means it has some number. So some number. And it has a direction. So this can be north, south, east, west, or it can be positive and negative. So this is a direction as well as your cardinal directions, north, south, east, west. A scalar quantity is magnitude only. So this is just a number. So an example really quickly would be, say, 400 meters per second north, negative 9.8 meters per second squared, so it should look familiar. Scalar quantity, some examples would be, say, 10 kilograms, 10 degrees Celsius, let's see, how about 40 meters? This one is a scalar because there's no direction to it. All right, so vectors. For vectors, an arrow is what we're going to use to represent a vector. So the length of the vector gives you the magnitude. So the longer the arrow is, the larger the magnitude. So for example, this might be 1 meter in scale, and this one would be 2 meters in scale. So the longer the arrow is, the larger the magnitude. The direction of the arrow indicates the direction of the vector. And so in this example, both of these vectors are going to the right or to the east, depending on exactly what scale we're using for the direction. So I'm going to use an arrow. How to draw them is by the head to tail method. So I'm going to just draw some examples, so hopefully it helps you realize what we mean by head to tail. So when drawing multiple vectors, always draw them head to tail. So here's one vector, say this is 2 meters long. And if we had an additional vector that would be 1 meter long, we would put the tail of the second vector at the head of the first vector. That way it forms a line. So head to tail. Let's say we had them going in opposite directions now. So here's 2 meters going to the right. And if we had 1 meter, but now going to the left, at the head of this arrow, I'll use a different color. The head of this arrow, we would have an arrow going to the right or to the left, 1 meter. So 2 meters to the right, now 1 meter to the left. Again, head to tail. What if we had them going in different directions? Let's say we had 2 meters going this way, and then we had 1 meter going south. Again, head of the first arrow is where we put the tail of the second arrow. So head to tail. And then, of course, if they were going in just random directions, you would still use head to tail. So head to tail. Make sure you draw them like this because it'll indicate your direction much easier because it matters what direction the arrows are pointing. So let's do an example doing 1D vector addition. So this should look very similar to what we've already done in terms of distance and displacement. So suppose a plane is flying west in a strong wind. If the velocity of the plane is 400 meters per second west and the velocity of the wind is 200 meters per second east, what is the resulting velocity of the plane? Well, let's draw this. So first, let's draw the velocity of the plane going west. So the plane is going west at 400 meters per second. Now, we have the wind going east. So at the head of this arrow, we're going to put the tail of the other. And so this is going in the opposite direction. So 200 meters per second east. So we have 400 going west, 200 going east, and what we care about is the start to end. This is what we're looking for. If they're going opposite directions, use subtract. So 400 minus 200 gives us 200 meters per second, and it's always in the direction of the larger, so it's going to be west. 200 meters per second west. This is also called a headwind, and you might see that in questions on WebAssign, in examples, on the test. It's a headwind because the wind is hitting the head of the plane. So you can imagine, oh gosh, here we go, my drawing skills. I apologize. So you can imagine the plane is flying in this direction. The wind is hitting the head of the plane. It's going the opposite direction. So now, let's assume that the plane turns around. So same velocities, but now the plane is flying with the wind. So our plane is again going 400 meters per second, but now instead of going west, it's going east. 400 meters per second. The wind is still going the same amount, and the wind is going 200 meters per second. And so at the head of one arrow, we're going to put the tail of the next. So this is 200 meters per second. If they are going in the same direction, here's our start, here's our end. So same direction means you're going to add them. So 400 plus 200 equals 600. That's meters per second, and they're both going east. So again, if we had a visual, see this time the plane is flying in this direction. Again, excuse my drawing skills. So the plane is going in this direction. The wind is now going in the same direction. So it's flying with the wind. This is called a tailwind. And it's because the wind is pushing on the tail of the plane, since they're both going in the same direction.